Hi, here is a nice and simple geometry problem. We have a big square with side length equal to 1. Inside of this square, we have a small square with side length 2r is connected with two circles are equally measured with radius r. So we have this diameter 2r for each circle, and we have the diameter of this small square as well. We have a diagonal of this big square as oriented is connected with this diameter of these two circles and diameter of this small square as well. So there is a small distance is connected between this second circle and this big square, okay, which is connected with these two circles and small square and this small distance as well, okay. By doing this one, I'm going to contract this small distance, okay. I'm going to extend this radius r, okay, to this line, and also so now we have a diagonal as oriented as this line, which is connected with this small square and two circles and the radius of these two circles and this small distance. Let's call this small distance t. Let's call this small distance t, okay, and this diagonal of this small square x. Now I have a diagonal of this big square equal to this distance x as a diagonal of this small square and diameter of this first circle and diameter of the second circle and this little distance t. Let's call this diagonal of this big square as a y equal to x plus this 2r plus this 2r. So we have 4r. We have the diameter of this first circle, which is 2r, and the diagonal of this and the diameter of the second circle is 2r as well. So x plus 4 plus this small distance t, okay. There is a bunch of ways for solving this problem. As you see here, as a center of this second circle, I'm going to do the projection line from this one. So as you see here, this is distance r as well. There is a tangent line of this side length of this square and this circle at this point. So by doing the extension from the center on this side length of this circle, there is 90 degrees. Also, I can do the same thing here. So there is two distances are equally measured as a radius of the circle. If you take a look at here, there is a small triangle here with a right triangle at this point. So these two sides of this triangle are congruent, okay. I'm going to apply the Pythagorean theorem here as a t square. So as you hear, so this distance r plus t quantity square. So we have this distance r plus t quantity square equal to this distance, which is r square as a radius of this circle, plus this distance, which is r square. So put them together is giving us 2r square, okay. I'm going to apply the square root on both sides. Since we have these distances are positive, so I will have r plus t equals square root of 2r, okay. I'm going to bring r to the other side, so I will have t equal to r is multiplied by square root of 2 minus 1, okay. So I have the first equation as you see it here. Let's call it equation number 1, okay. So the second thing I mentioned here, so I'm going to apply Pythagorean theorem on this big triangle. So I'm simply going to apply the Pythagorean theorem on this big triangle. I will have y square, y square equal to 1 square plus 1 square, which is 2. So now this equivalent y equal to square root of 2. Okay, so I'm going to evaluate x as well. So same thing here. In this small triangle I have x squared. I'm applying the Pythagorean theorem as well here on this triangle. This distance we already have equal to 2r, which is 2r quantity square plus 2r quantity square. So this distance, all this side length are equally measured because we have a square here. So this one 2r square, which is 4r square plus 4r square, which is 8r square. Okay, since x and r are positive, okay, so x equal to square root of 8. So I'm going to plug all this information into this first equation, which is y. So y equal to x, which is this distance, 2 square root of 2 r plus 4r plus t. T is equal to r is multiplied by square root of 2 minus 1. Now this y was already evaluated, so I'm going to calculate this one. So we have 2 square root of 2r plus this r square root of 2. So we have 3 square root of 2 r, 4r minus equals square root of 2. So we already calculate y equal to square root of 2. So this one equivalent r equal to y, which is square root of 2, which is 1 over 3, is multiplied by square root of 2 over square root of 2 plus 1. Okay, here is the value of r. What I'm going to do now, I'm going to rationalize this one by multiplying numerator and denominator by square root of 2 minus 1. So I will have r equal 1 over 3 square root of 2 is multiplied by square root of 2 minus 1 over square root of 2 plus 1 is multiplied by square root of 2 minus 1. Finally, we found r equal to 1 over 3 is multiplied by 2 minus square root of 2. So now r equal 1 over 3 is multiplied by 2 minus square root of 2. This is the value of r. So I have done with this problem. Thank you for watching. I will see you in next video. Bye.